Okay, we're looking at mixed exercise 6 from the first year core textbook. So we're looking at circles and we're on question 19. So we've got an exam question, which is good because we can see how many marks each part's worth. It's also problem solving, so we're going to have to think carefully about how to tackle it. So they start us off with an equation of a circle. So it's in its expanded form, but all the information is there. And then we've got two lines which are both tangents. And we're told that they both go through the point 0, 6. Okay, so part A, we want the equation of those two lines. Okay, so let's do our own just quick sketch. Okay, so it's not looking very tangenty, but that'll do. Okay, so those two tangents, they are both going to obviously have equations in the form y equals mx plus c because they're straight lines. But as I know that they both go through 0, 6, they both actually have a y-intercept of 6. So probably for my first maybe B1 mark, I can say, well, actually, they're both going to be of the form y equals mx plus 6. Okay. Well, so what would I do? And we're after... oh, no, sorry, I was going to say we're after the points of intersection. We're not, but that's for part B. But I know that both of these lines just touch the circle. So if I was trying to find the points of intersection, then there is only one. So that's making me think about the discriminant. So the circle has the equation x squared plus 6x plus y squared minus 2y equals 7. Okay, so let's say I was trying to find where the straight line and the circle intersect. The best way to do that is going to be to substitute in mx plus 6 for y. So substitute the straight line into the circle. And for this part of the question, I don't need to complete the square on the circle and find its centre and radius. I might do that later on. So I can just have it in its expanded form. So that's going to be x squared plus 6x, and then where it says y, I'm going to substitute in mx plus 6, and again, where it's 2y, I am substituting in mx plus 6. Okay, so I've got a quadratic in x, but obviously I've also got that unknown gradient m. But so first of all, let's expand all these brackets out and simplify. So the mx plus 6 all squared is mx plus 6 times mx plus 6. It's up to you if you need to just write that out with some separate working. So that's going to give me m squared x squared. Then I'm going to have 6mx twice, so that will be 12mx. I'm going to have 6 times 6. Oh, sorry, and then I've missed out the minus 2 next set of brackets. Right, so then I've got minus 2mx and minus 2 times 6, and that will equal 7. Okay, so let's collect all our like terms together. So there's I've got 2x squared terms, and what I'm going to do, so rather than write them out as two separate terms like that, I'm actually going to factorise and take 1 plus m squared out as a common factor. Okay, so for my x terms, I've got the 6x, the 12mx, and the minus 2mx. So that would give me 6x plus 10mx when I do the 12x minus the 2mx. But again, I'm actually going to factorise. So take 6 plus 10m out, just so I can have it as a single x term. And then the constants are nice and straightforward. So I've got 36 minus 12, so 24, and then I'm going to minus that 7. So then I've got plus 17. Okay, so I know that if I just try and get everything into the same, let's try and stop that bobbing around. Okay, so I know that. So basically, I'm structuring it as though I'm trying to find where the straight line and the circles cross. Obviously, I can't do that because I don't know m. That's going to be part B of the question. But I do know, I know it doesn't look it in my messy sketch, but they're only supposed to touch once. So I know that this quadratic I've ended up with should only have one solution or a repeated root, And that happens when the discriminant is 0. So this is where I wanted to factorise my coefficients, so I can clearly see that A is 1 plus m squared, B is 6 plus 10m, and C is 17. So if I then substitute them into a discriminant, so b squared minus 4 times a times c, and that equals 0, because there should only be one solution to this. Okay, so if I square out those brackets, I'm going to have 6 times 6. I'm going to have 6 times 10m twice. I'm going to have 10m times 10m. And then don't forget, so when you're multiplying these brackets out, so you're multiplying by 4 and 17. So I'm going to have so the minus 4 times the 1 times the 17 is minus 68. And the minus 4 times the m squared times the 17 is minus 68m squared. So now I've got a quadratic in m. So I've got 100m squared minus 68m squared. I've got just 120m, and then I've got 36 minus 68. Okay, and that is going to cancel down, but I'm feeling lazy, so I'm just going to stick it straight into my calculator. So A is 32, B is 120, C is minus 32, and that is giving me either m of a quarter, so obviously on my calculator it's coming up as x, but the quadratic was in m, or minus 4. Okay, and if I have a quick check back to I'll look at their diagrams, it's a lot neater than my sketch, see if that seems okay. And I would, as much as I can check it, I think I'm quite happy with that. So line 2 will be the one with the gradient of a quarter, so a positive gradient but not very steep. And line 1 would be the gradient of minus 4. So we'd already said that they both had a y-intercept of plus 6. We had to use that in our working. So my equations are going to be y equals a quarter x plus 6, and y equals minus 4x plus 6. And I can say as well which is which. So line 2 is the not very steep positive gradient. So that one's line 2, and line 1 is quite steep in the negative gradient. So that's line 1. Okay, so find the points of intersections P and Q. So find the points of intersection P and Q of the tangents in the circle. Right, so where do those tangents touch the circle? Well, we've already kind of structured our answer for that, because that's what we were doing here. Yes, so to go to a different colour. Yeah, so actually we could just substitute our value, we could just substitute our new value of m into that, and that's the quadratic we would solve. So if you're happy with that, then you can just go straight to that. If you're a little unsure, because obviously we've got quite a few quadratics flying around the place, we could just do it again from scratch. So if I do, so if I substitute this one, let's do this one first just because it doesn't have a fraction. So if I substitute this into the equation of the circle, I would get x squared plus 6x plus y squared minus 2y equals 7. Okay, so you could go back and do that again, but if we then look back to the bit I highlighted in blue, that's all that is. So that's basically the line I've just written, that I've used minus 4 for m. So we'd actually already done the simplifying of that. So our best bet would be to go to that. So let's do that. So you can do it either way. We'll go, just about get on the same page. So I'm going to go back up to this blue highlighted line. Make that any smaller, yeah. Okay. So I'm going up to the top of the page where I've highlighted in blue. So I'm not going to just re-simplify all that. So 1 plus m squared, well, if m is minus 4, that's 1 plus 16. So that's 17x squared. 6 plus 10 times minus 4, so that's 6 minus 40, so that's minus 34, not 36. That's minus 34x plus 17. Okay, and but that's exactly what you would get if you just simplify that again. So obviously that cancels through by 17. And then that factorizes to -1 and -1. And we knew there was going to be repeated roots. Yeah, remember that was sort of the whole premise of using the discriminant. So we knew this was going to factorize to repeated roots. So we get x is -1. This is the one I'm using at the moment. So if x is -1, y is -4 times, sorry, yeah, x is +1, sorry, y is -4 times 1 plus 6. So y is 2, so my first answer is 1, 2. Okay, so then we do exactly the same thing, but using m is a quarter. So, right, so let's go really small. Okay, so again, I'm going back up to this line here. So if m is a quarter, that is going to become, so 1 plus a quarter squared is 17 over, 17 over 16x squared. Then looking at that, if m is a quarter, it's going to be 17 over 2x and plus 17. Okay, and again, I'm just going to stick that to the calculator. You can multiply through by 16, but it's the easy option. Okay, so A is 17 over 16, B is 17 over 2, C is 17. And remember, I'm expecting a repeated root. So when I stick that to my calculator, I'm getting x is -4. So even though I've got x in my calculator, I'll still put that in just to show you some working. But I've got the repeated root of -4, and then if I go to, so this is the equation we're using here. So if x is -4, y is a quarter times -4, so -1 plus 6. So y is 5, so my second intersection is that. And then I'm just going to go back to the question and see if I can, let's make this a bit bigger again. Okay, so let's just say, yeah, so I can say which is which. So this was the point of intersection I got when I was doing -4x, so line 1. So that is that coordinate there, so that is Q. So this one, therefore, must be P. And I mean, we could also judge that from the facts, so let's move that up a little bit. But we could also tell that from just looking that obviously that's x and y are both positive there, x is negative, and y is positive there. So that has to be that one. Right, okay, and then, so although we're after an area of a quadrilateral, which sounds like it could be a bit of a nightmare, this is only worth 2 marks. So this really should just be interpreting what we've got, hopefully. So what are we doing? A, P, R, Q. Okay, right, let's have a think. So we could, okay, so let's just quickly sketch that out. So we've got that tangent that's touching at P, we've got this one that's, oh sorry, I can't see that, scroll up a little bit, touching at Q, and we know the coordinates of P and Q, we've got A, and then R is the intersection. Okay, well, I know that the radius and the tangent will be a right angle, so that's always helpful. So in fact, if I change to eraser, so I think about that triangle, if I can get that length, and I'll call that the base, and that length, and I'll call that the height, and I know that that's a right angle, I can do the area of that triangle, and then I'm going to have exactly the same triangle in blue there. So if I find the area of the red triangle and then double it, I'll have the total area of that quadrilateral. So to do that, I need the distance RQ. Well, that's fine. R was 0, 6, and Q was 1, 2. So RQ is the square root of 1 minus 0 all squared plus 2 minus 6 all squared. So 1 squared plus 4 squared. And I'm not going to, sorry, which is not root 5. Right, 1 squared plus 4 squared. And I'm not going to bother simplifying that because I just wanted to substitute into half base times height. P is, oh sorry, no, I don't need to do P because I'm just going to find the red triangle. So A, right, we haven't specifically said what A is. A is going to be the centre of the circle. So you might just be able to sort of see what that's going to be without having to write the working out, but let's do it just in case. Okay, so I don't need, oh, actually, no, sorry, I do need the radius. Yeah, so I'll tell you what I could do. Let's just find the radius of the circle. That's an alternative. It's probably a bit quicker, right? So B, what I'm calling the base of my triangle is just the radius of the circle. So if I complete the square, so x plus 3, and then I need to minus 9, y minus 1, and I need to minus 1. So yeah, so I was going to make it a bit long-winded. I was going to find the centre and then find the distance from the centre to Q, but actually I've got that. So if I add the 9 and the 1 over, and then that's r squared, we know from the equation of a circle. Okay, so that's interesting. So actually I'm getting an isosceles triangle, which is fine. Yeah, so I might have missed something there. I might have been able to conclude that anyway, but I'm getting AQ also is root 17. So the area of the red triangle is half times base times height. So that is going to be, well, half times 17, isn't it? Right. So 17 over 2. So, just get rid of that, so I can carry on working there. Okay, so that's the area of the red triangle. So that's the area of the triangle. So in fact, yeah, let's just make it clear that's the triangle. So the area of the quadrilateral they asked for, which is going to be double that. So hopefully 17. Okay, let's just check that. Okay, so thank goodness for that. Okay, I'll just check the others. Yeah, P and Q we got, and we've got the two equations. It's quite a long one, that one.